Good evening. In the last lecture, we discussed permutations of n things taken all at a time, but all are not distinct. Some of them are similar. Okay. Exercise 3.4, third sum. A coin is tossed 8 times. In how many ways can we obtain A part, 4 heads and 4 tails? B, at least 6 heads. Solution: a coin is tossed 8 times, so the number of possible trials is n equal to 8. Now outcomes are either head or tail, provided it's a fair coin. So 4 heads means remaining 4 tails. So number of ways in which we can obtain 4 heads and 4 tails is n factorial upon p factorial into q factorial. That is 8 factorial upon 4 factorial into 4 factorial. On simplification, you get 70. B part, at least 6 heads. At least 6 means what? Either 6 heads or 7 heads or 8 heads. But when we say 6 heads, at the same time, we have to say 6 heads and 2 tails, or 7 heads and 1 tail, or all the 8 heads. So what is the number? 8 factorial upon 6 factorial into 2 factorial, because head is repeated 6 times and tail twice, plus or means addition, because when we say there are exactly 6 heads, how can there be exactly 7 heads? So either 6 or 7 or 8, or means addition, plus 8 factorial upon 7 factorial into 1 factorial, plus 8 factorial upon 8 factorial into 0 factorial. So if you simplify, you get 37. So 37 is the answer. Fourth sum. A bag has 5 red, 4 blue and 4 green marbles. If all are drawn one by one and their colors are recorded, how many different arrangements can be found? First we discuss the solution and then we'll write. See, total number of marbles is what? 5 plus 4 plus 4, that is 13. Of which 5 are red, 4 are blue and 4 are green. So number of distinct arrangements is 13 factorial upon 5 factorial into 4 factorial into 4 factorial. I repeat, it is 13 factorial upon 5 factorial into 4 factorial into 4 factorial. Okay, write down. Solution. There are 5 red, there are 5 red, 4 blue and 4 green marbles. That is in all 5 plus 4 plus 4 equal to 13 marbles. 5 plus 4 plus 4 equal to 13 marbles. Therefore, number of distinct arrangements equal to don't simplify this, 13 factorial upon 5 factorial into 4 factorial into 4 factorial. Sum number 5. Find the number of ways of arranging letters of the word mathematical. How many of these arrangements have all vowels together? Write down. I'll dictate the solution. There are 12 letters. Please write. There are 12 letters in the word mathematical. There are 12 letters in the word mathematical. which include M, capital M twice, comma, A, capital A thrice, and T, capital T twice, capital T twice. And the rest are all different. And the rest are all different. Therefore, total number of arrangements equal to write down this, 12 factorial upon 2 factorial into 3 factorial into 2 factorial. Don't simplify this. So this is the first part. Next line. The vowels are A, E, A, I. The vowels are A, E, A, I. That is 4 vowels. That is 4 vowels which include A twice. Which include A, capital A twice. See, you have to write all these things if you want full marks. Which include A twice. These 4 vowels can be arranged. These 4 vowels can be arranged in 4 factorial upon 2 factorial ways. Just a minute. Uh, A. I'm sorry. Basically, A is followed by E, is followed by A, is followed by I. I'm sorry. In fact, there are 5 vowels in which A occurs thrice. Yes, you are right. I'm sorry. Okay. So please make that correction. The vowels are, just make the correction. Don't cancel everything. Vowels are A, comma, E, comma, A, comma, I, comma, A. That is 5 vowels in which A occurs thrice. A occurs thrice. Therefore, vowels can be arranged amongst themselves. Vowels can be arranged among themselves in 5 factorial upon 3 factorial ways. Okay. Next line. Considering 5 vowels as a single letter. Considering 5 vowels as a single letter. Considering 5 vowels as a single letter. We have 7 plus 1, that is 8 letters. See, in all there are 12. Exclude this 5, so 7, and we have treated this 5 as 1 because they move as a unit. Okay, so that is 8, which include M twice, and T twice. Therefore, number of arrangements equal to, therefore, number of arrangements equal to 8 factorial upon 2 factorial into 2 factorial. Next line. Hence, the number of arrangements, in which vowels are together, hence the number of arrangements in which vowels are together is, see on the screen, write down this, 8 factorial upon 2 factorial into 2 factorial into 5 factorial upon 3 factorial.
Find the number of different arrangements of letters in the word Maharashtra. How many of these arrangements have A. Letters R and H never together. B. All vowels together.
Okay. See, in the word Maharashtra, there are how many? 11 letters, in which A occurs 4 times, right? H twice and R twice, and the rest are all different. So what is the total number of arrangements? It is 11 factorial upon 4 factorial into 2 factorial into 2 factorial. Once 4 factorial gets cancelled, 5 into 6 up to 11, 2 factorial is 2, same. So on simplification, you get this 4,15,800. Okay, write down. There are 11 letters in the word Maharashtra. There are 11 letters in the word Maharashtra, which include A 4 times, comma, H twice, comma, R, capital R twice, capital R twice, and the rest are all different. Therefore, total number of distinct arrangements equal to, write down this. It comes out to be 4,15,800. A part. Actually, we are asked to find number of arrangements in which letters R and H are never together. Okay, we will consider the complement that they are always together and we'll subtract that number from total number of arrangements. Okay, write down. When 2R and 2H are together, when 2R and 2H are together, comma, we consider them as one letter or one unit. We consider them as one letter. Therefore, we have to arrange. Therefore, we have to arrange we have to arrange 7 plus 1 equal to 8 letters. 7 plus 1 equal to 8 letters, which include A 4 times. Which include A 4 times. Therefore, number of arrangements equal to. Therefore, number of arrangements equal to 8 factorial upon 4 factorial. 8 factorial upon 4 factorial. Also, 2R and 2H, that is these 4 letters. Also, 2R and 2H, that is these 4 letters, can be arranged in 4 factorial upon 2 factorial into 2 factorial ways. 4 factorial upon 2 factorial into 2 factorial ways. Therefore, number of arrangements in which both R and H are together equal to, see on the screen, equal to 8 factorial upon 4 factorial into 4 factorial upon 2 factorial into 2 factorial. Find the value. In the first part, after cancelling 4 factorial, what remains is 5 into 6 into 7 into 8. Now 4 factorial is 24 upon 2 into 2. Now if you simplify this, you should get 10,080. Therefore, number of arrangements in which R and H are never together will be what? From the total number 4,15,800, subtract this 10,080. See what you get. I think 4 lakh will be what? 4 lakh 5,720. Is it? Yes. Right now. Now in the P part, what is asked? All vowels are together. Let me explain first and then I'll dictate the solution. Tell me how many vowels. In fact, 4 vowels, but each vowel is A. Okay. So we consider these 4 vowels as a single letter. Okay. So this letter and remaining 7, that is 8 letters are to be arranged, don't it? Now these 8 letters include H twice and R twice. So upon 2 factorial into 2 factorial. Now these 4 vowels can be arranged among themselves in how many ways? One way only, because each of the 4 vowels is A. Okay. So this is the final answer. Write down. There are 4 vowels. There are 4 vowels. Inside the bracket, write down. Each is A. Each is A. Capital A. Bracket complete. We consider 4 vowels as one unit. We consider 4 vowels as one unit. Then we have to arrange. 7 plus 1 equal to 8 letters. 7 plus 1 equal to 8 letters, which include H twice and R twice, which include H twice and R, capital R, twice. Therefore, total number of required arrangements equal to right now 8 factorial upon 2 factorial into 2 factorial. So what is the value? See, 7 factorial is 5040, right? Multiplied by 8 upon 2 into 2, that is 4. So again we are getting 10080. Okay. In the next line, write down this. In the next line, we should mention this also. First complete this. Next line inside the bracket. 4 vowels can be arranged among themselves. 4 vowels can be arranged amongst themselves in 4 factorial upon 4 factorial equal to 1 way. Bracket complete. Seventh is for homework, simple one. How many different words are formed if the letters are used thrice? The letter S and T are used twice each. So 7 letters, 7 factorial upon 3 factorial into 2 factorial into 2 factorial. Okay. But don't write this as the answer because explanation is required. Sum number 8. Find the number of arrangements of the letters in the word Mumbai so that the letter B is always next to A. Okay, so we need AB, right? Letter B is always next to A. Okay, right now. There are 6 letters. There are 6 letters in the word Mumbai. There are 6 letters in the word Mumbai. Which include M, capital M twice. Next line. Letter B should always be next to A. Madam, letter B should always be next to A. That is, we need AB. That is, we need AB. Full stop. We treat this as one letter. We treat this as one letter. We treat this as one letter. Therefore, this letter and remaining 4, therefore, this letter and remaining 4, that is 5 letters, are to be arranged. That is 5 letters are to be arranged inside the bracket, which include M twice, which include capital M twice, bracket complete. Therefore, number of arrangements equal to number of arrangements equal to 5 factorial upon 2 factorial. That is 120 upon 2 equal to 60. Okay. Now you may ask me, but A and B can be arranged among themselves in 2 ways. No. What is the requirement? Letter B is always next to A. So BA is not required. Only AB is required. So 60 is the final answer. This is for sum number 8. Ninth one. Find the number of arrangements of the letters in the word constitution that begin and end with N. Okay. So how many N? Constitution. So 2 N's. Okay. So that problem is solved. Basically, just a minute. There are 12 letters in the word constitution, right? Don't write the solution. First, I'll explain. There are 12 letters in the word constitution in which N occurs twice. Okay. O twice, P thrice, and I twice. Okay. Now 2 N's are fixed, right? First and last. means we have to arrange 10 letters, which include O twice, T thrice, and I twice. So this is the number, right? Okay, write down. In the word constitution, there are 12 letters. In the word constitution, there are 12 letters. There are 12 letters, which include N, capital N, N twice, comma, O twice, comma, T, capital T thrice, and I twice. Next line. Each arrangement is to begin and end with N. Each arrangement is to begin and end with N. Therefore, we have to arrange remaining 10 letters. Therefore, we have to arrange remaining 10 letters which include O twice, T thrice, and I twice. Therefore, total number of required arrangements equal to write down this 10 factorial upon 2 factorial into 3 factorial into 2 factorial. Has anybody found the number by substituting the values? See, 7 factorial we know 5040 into 8 into 9 into 10 upon 2 into 6 into 2. But in exam, you can write this as the final answer. Now this is an important sum. How many distinct 5-digit numbers can be formed using the digits 3, 2, 3, 2, 4, 5? See, degree of difficulty is increased because we are given 6 digits and we are asked to form 5-digit numbers, and in those 6 digits 2 is repeated twice, 3 is repeated twice. Okay, so we have to form 5-digit numbers from these digits. First case, number of 5-digit numbers formed by the digits 2, 2, 3, 4, 5 is what? 5 factorial upon 2 is repeated twice, so 5 factorial upon 2 factorial, that is 60. Second case, number of 5-digit numbers formed by the digits 2, 3, 3, 4, 5. Here 3 is repeated twice, so it is again 5 factorial upon 2 factorial, which is 60. Third case, number of 5-digit numbers formed by the digits 2, 2, 3, 3, 4. Here you will notice that 2 is repeated twice, 3 is repeated twice. So number is 5 factorial upon 2 factorial into 2 factorial, that is 30. Fourth case, number of 5-digit numbers formed by the digits 2, 2, 3, 3, 5. So again 5 factorial upon 2 factorial into 2 factorial, that is 30. So considering all these cases, see, these are the only 4 cases which are possible. So total number is 60 plus 60 plus 30 plus 30, which is nothing but 180. Actually, in this exercise, we are solving sums in which permutations of n things, not all distinct, but taken all at a time. But in sum number 12, you will notice, I hope I'm right, that all the digits are distinct. Okay. Anyways, we'll solve that. Sum is find the number of distinct numbers formed using the digits 3, 4, 5, 6, 7, 8, 9, so that odd positions are occupied by odd digits. Okay. So write down. Digits are, write down, digits are 3, 4, 5, 6, 7, 8, 9. There are 4 odd places. There are 4 odd places inside the bracket. First, third, fifth, and seventh. Inside the bracket. First, comma, third, comma, fifth, and seventh. Bracket complete. And 4 odd digits. Therefore, odd positions can be occupied by odd digits. Therefore, odd positions can be occupied by odd digits in odd positions can be occupied by odd digits in 4p4 equal to 4 factorial equal to 24 ways. Also, three even positions can be occupied. Three even positions can be occupied by 3 even digits. By 3 even digits in 3p3 equal to 3 factorial equal to 6 ways. Therefore, total number of arrangements equal to 24 into 6, that is 144. Sum number 13. How many different 6-digit numbers can be formed using digits in the number 659942? How many of them are divisible by 4? First part is simple one. Write down. There are 6 digits which include 9 twice. Write down. There are 6 digits which include 9 twice. Of course, 0 is not there. Therefore, 6 factorial upon 2 factorial, 6 factorial upon 2 factorial equal to 360 numbers of 6 digit can be formed. Therefore, 6 factorial upon 2 factorial equal to 360 numbers of 6 digit can be formed. Next line. Number formed will be divisible by 4. Number formed will be divisible by 4 if last two digits are write down 245256649296. See, be careful. 9 occurs twice, so we have to consider two cases. Write this much only. Next line. Case 1. Case 1. When the last two digits are 24, 52, 56, 64, then the remaining 4 places can be arranged. Then the remaining 4 places can be arranged in 4 factorial upon 2 factorial equal to 12 ways. 4 factorial upon 2 factorial equal to 12 ways. Why? Because 9 occurs twice, 12 ways. So 12 possibilities for 2, 4, 12 possibilities for 5, 2, 12 for 5, 6, 12 for 6, 4. Okay. Next line. Therefore, 4 into 12 equal to 48 such numbers can be formed. 4 into 12 equal to 48 such numbers can be formed. Next line. Second case. When the last two digits are 92 or 96, remaining 4 digits can be arranged. Remaining 4 digits can be arranged in 4p4 equal to 4 factorial ways. 4p4 equal to 4 factorial ways. That is 24 ways. Therefore, 2 into 24 equal to 48 such numbers can be formed. Therefore, 2 into 24 equal to 48 such numbers can be formed. Now you will ask me why 24 into 2. See, first case is last two digits are 92. So 24 such numbers. Last two digits are 96. 24 such numbers. So 24 into 2, that is 48 such numbers. Next line. Considering above cases, total number of numbers equal to 48 plus 48 equal to 96. So that's it for today.